السلام عليكم ورحمة الله تعالى وبركاته. This is Associate Professor Dr. Abdurrahman Al-Suwari. Today here I'm going to present WHKS web-based combinatorial testless generation strategy based on hybrid kidney algorithm. The team members Amin Ali Bahmid and Professor Kamal Zamli. As you know that our life depends on the software in every part in our life. So we have to create or built a very quality software that will not fail in any defects. So if this software fail in the defects, so will causes a lot of disaster things. So one of the we are based on Internet of Things, and also every part in our life is connected to a software. So we need to test that software. If we want to test a software, for example, we have this system have 5 inputs. So each input have optional 2 values. So if you want to test all possible combinations, so for here we have a possible of 32 test cases to test all the possible combinations. But imagine that now in our life all the system very complex and have more than only 2 options. Maybe we'll have 10 inputs and each input have 5 values. So if we imagine that how many test cases required, it needs 9 million test cases need to be executed. If each one test case require 3 minutes only to be run, then it needs 50 years to finish or run the testing. For that, it is exhaustive testing is impossible. It means test every part in the system is very impossible. Here, introduce the combinatorial testing. Combinatorial testing, it will come to generate the final test list based on the combination degree. So we can see that it can reduce the number of test cases and also cover the most critical part in the system. And these test cases, we can only generate only 41 test cases instead of 9 million test cases based on the given information during generating the test cases. Here we save 99% of the cost and time effort that will be used during the testing. So to select the optimum test cases, this is NP hard problem, which is an optimization problem. From that, we introduce optimization algorithms. There are many techniques in the markets, combinatorial testing strategies in the market. Most of them, they are based on combinations or computational process, but that they don't support high degree of combinations. From that, and also there are some of the published algorithms or published strategies based on hybrid algorithms. Here we propose a new hybrid algorithm based on the original kidney algorithm, but here we improve the kidney algorithm by introduce a new conditional control here. It's called improved kidney algorithms, but this improved have some limitation, which is it will has the solutions, it will not be better than the original kidney. And we introduce a new mutation kidney algorithm by introduce a new operations here and in 2 places here and also in this part by replacing the equation here. So these algorithms will improve the solutions, but the time will be more to avoid the limitation in both here, avoid not generating the best results, and here generating best result but take time here, not best time but not best results. So we combine these 2 algorithms into this algorithm. We introduce a hybrid kidney algorithm, and this algorithm have been implemented in the combinatorial combinatorial testing problems. So here all the algorithm will be built here, and we generate the test cases. For example, if we have a system that consists of 4 inputs, 4 parameters, and each input got 5 values. So first, with this algorithm will generate the pairs, and then this interaction list will generate the possible combination between all the inputs between each two here, because here the pairs between each two parameters. Here are the interaction list between each two inputs. And then we generate the final test list based on this interaction list. We validate that this algorithm is work, or this strategy is work, and cover all the interactions between the inputs of the system. That input of the system, it's suggested by expert testing, and it can be vary up to 6. We can change the values here, the combinations. So we can see that it will generate minimum of the test cases. We apply this algorithm in many benchmark functions, so that we can see the hybrid algorithm, it's outperform the improved kidney algorithm and the mutation kidney algorithm in terms of the optimum size with a very fast process. To evaluate this hybrid kidney strategy, combinatorial kidney strategy, we compared with 110 uniform combinatorial testing experiments. We can find that the HKS or WHKS produce the most optimum results with 60% of this 110, and it has only around only 17%, which is close to the optimum, while the others is not comparable to the our strategy. Also, in terms of comparing with the supporting variable interaction strength, so this strategy supports variable interaction strength. Also, it produces 78% better or near to the optimum result compared to the others. And also for input output features, which is the first, this is the first strategy that support input output based on optimization algorithms. If we can depends on the literature, no one of the existing combinatorial testing strategies based on the optimization algorithm support input output. We can see that this algorithm, it produced the optimum results in all the experiments, the 12 experiments, compared to the other existing strategies. Among all the 152 experiments, we can find that this algorithm, the proposed or the developed HKS, has produced 67% optimum results compared to the only the this one particle swarm based, it's close to us, but it's only 58, while the others is very far compared to our strategy. Based on our work here, we managed to publish the combinatorial test list generation based on also harmony search algorithms, which is Web of Science Q1 in ambient intelligence. And also we managed to publish in IET software engineering, which is adopt elitism greedy algorithm for variable strength combinatorial test generation. And we have we have already get our manuscripts in engineering applications artificial intelligence Q1 journals. The hybrid this one title is hybrid kidney algorithm based on the problem generation combinatorial testing. And also we have published one conference and got the acceptance and already published. And based on the previous work, we have this algorithm has a copyright based on Java, and we already submitted for the web-based support. We have a collaboration with Technology Solutions, and they have been use this strategy to generate a test list during the testing process for their projects, and it's show that 90% of the interface defects have been detected based on the generated test cases. In the commercialization, we can see that this WKS can be affordable by 6,000 based on copy, or if we give them the Java platform, or they can also access in the website by 6,000 ringgit for unlimited, no limited times to be used, and the number of users. there is no they can access there. And also it support uniform variable strength input output compared to the existing. So while there are existing tools here, the price for this hexawise is 8,000, but only for a 1 year, and it needs only uniform and online. Ours is online also, and portable, can be run in Java. If you don't have access to the internet, you can download the portable and can run it in your device. Also, there is a test cover. It's 450, but this one based on 1 month. And also there is a protest. So the novelty of this work, it is the first combinatorial test list generation based on web-based, has been implemented based on hybrid kidney algorithm and support uniform variable strength input output seeding interactions and the interaction degree up to 6. We use these tools during software testing subjects in the lab, when we test the student how we generate generated test cases automatically instead to use them manually, because we cannot, it is impossible to generate a test cases for hundreds of inputs. So we use some of the existing tools. One of the existing tools during the lab in the teaching, it's HKS. Based on that, I can demo the algorithm. You can see this one. This is the tool, is web-based. We can just register the user. We just use login based on the username and password. After login and then he can go to the main page. We can even generate virtual if he has maybe five inputs, 2 values. This is the values, and then we can generate the test list for the given inputs and outputs. This is the test list. Also, we can give a mix covering array, which is we can give values like 3 parameters, 2 values, 2 parameters, or 2 values, 3 parameters. And then here we can see that there are 3 parameters, 2 values, and 2 parameters, 3 values. We generate the test case. We can see only 6 test cases. And we have also for the real data, also is can be read from files, and we can see that it generates the most optimum test list. And also we can use the portable. This is also the tool, the same tool, but this one is portable. If you don't have internet, connect to the internet, you can use this tool by even the input here. You can key in the input of the data, or you can read from the existing. We can request from the users to let's say from this. So let's say if I have an example here, they have to okay, system 1. So this is system 1, have 4 inputs, and then say then we go to the generate. Okay, then we can go to the here window. We can generate. See, this is the inputs, and then just generate based on the combination degree 2 or combination degree up to 6. But here only 4 parameters. Then we can generate. You can see it will generate based on 30 run here. If you want to get the best size among during 30 process or 30 iterations, and then it will generate the optimum results, which is 8 test cases. If we want to reduce the time, so you can see here generate only 8 test cases. If you can reduce the time, you can here reduce it to only 4 times or 1 time, let's say, and then you can run again, just only will generate for 1 time. If you want to read from virtual, because if I want to show for 50 inputs and you have 2 values for each one. So here we clear first, and this is 50, and this one is 2 values. So you can see here 50 inputs. Let's go and generate for only 50 here. So you can see here 50 inputs. We can, if we generate the how many test cases that required to cover all, you can see it generate only 13 test cases instead of generating 1000. The most test cases will be 1200. We reduce it to only 13 instead of 2 times 2 to power, 2 to power 50. It is the total number of test cases. Here we reduce to only 13. We reduce the test cases to only 13. You can use this tool by also reading from files. That files will be prepared by a testers, and also you can key in. You can see here some of the existing combinatorial testing or called pairwise testing tools, and we have exawise, all pairs test case, and also there are many others. Some of them they are web-based, some of them are commercialized, and some of them free, but they are coded here, which is cannot be friendly, user friendly, and they don't have any interface. This is only under command prompt, and also only support uniform, and the interaction strength is very low, and they cannot go up to 32 inputs. And also all these here cannot support up to 32 inputs. Most of them they cannot support inputs to 100, while our tools can support more inputs, reach to 500 inputs. Depends on the memory of the PC. And also this project has been supported by PRGS, input output test combinatorial testing based on kidney algorithm, which is here the progress we already almost this is input output intelligent combinatorial test case generation based on kidney inspired algorithm with oppositions, and the progress report of this already achieved with these points, and with the amount have been approved by 68 75 ringgit. And also we have also another FRGS for novel kidney algorithms. This also there is a FRGS, a novel kidney algorithm, so also this project supported based on FRGS and a novel kidney inspired algorithms, and also already achieved, and the progress already achieved, and approved by supported by 65,000 ringgit. Thank you.